What up, what up, what up? Hello! Hello, happy Tuesday. Freaking... It still, like, crazes me that January's already over, and freaking... I'm not even used to hearing people say 2025. Not even used to hearing people say 2025. The other day, I was in a Discord call and they were talking about, like, old takes, and she's like, that's the 2020 take. And one of the other people was like, what's the 2025 take? And I was like, 2025 take, brick. But life moves fast, I guess. Life moves fast, and the world changes, and that's why today we're doing things that people never intended to do, and building games in MATLAB. Building games in MATLAB. Oh, I have to move kind of quick. I don't have a ton of time tonight. I've got homework to do, and I've got the cleaning lady coming in tomorrow. And I've thoroughly rot-maxed my apartment, so I have to do, like, the pre-clean, the pre-tidy tonight. I have to do that, and then I have to do a bunch of homework for tomorrow. So we gotta move. Let's go. It's still 2020. Yes, it's still 2020, and I am definitely still nice and young and definitely not a hag. Quickly switch our thing to... Twitch has a game development category, right? Game... Software and game development? Easy. Okay. Okie dokie. Before we start, I'm going to preface, I have not done this before. I have not built games in MATLAB before. I'm just like 80% sure I can do all of this. And I know people have built games in MATLAB before. I know someone has already built Tetris in MATLAB. But I want to do it myself, even though it's going to be way more scuffed. And even though this program is definitely not made to do this. But even though I haven't tried it yet, I also have like a sort of general idea of how we're going to approach this. So let's go over the game plan. Here. New. Okay, so if you haven't worked with MATLAB before, wow. MATLAB stands for Matrix Laboratory, which basically means it's your TI-84 calculator on steroids. And its real specialty is working on what are called matrices, which are really just sets of numbers that look like they've got this format and they're like 1, 2, 3, and they're in like these boxes. But they're arranged like that, right? That's not really, you know, what Tetris looks like. Of course, Tetris is obviously not a bunch of numbers, but Tetris is this same sort of shape, right? It's really just a bunch of boxes, right? Where you might have 3 in like this T shape. You might have a line up here. And really all it is it's a grid filled with these boxes. So we can actually pretty easily match it up with the matrix, and we're just gonna say, this is going to be the first spot on the grid. This is gonna be the second. This is gonna be the third. And what we're gonna do is we're going to make a big grid with all the numbers, and they're gonna be zeros for nothing there, and then if we wanna put a box there, it's gonna be a 1. Or something else, right? I think towards the later cycle of development here, we're going to want, you know, to be able to make boxes different colors and make them different, so we might end up with different numbers, but the general game plan is we're gonna do zeros for empty space, and non-zeros for space that, like, should have something there. And because obviously, like, this doesn't look very Tetris-y, and you could technically play Tetris with, like, numbers, we obviously want to make it look a lot better, and we want to make it actually look like boxes. Which MATLAB is oddly good at doing, because MATLAB is really good at, like, drawing plots and drawing graphs, so we can easily convert a matrix of numbers into a bunch of boxes or empty space. So that's the general game plan. Today, I don't know how far we're gonna get, but the game plan is to get to a point where we can have a game that will draw a game state based off of a matrix that we put in, right? So we'll be able to create a matrix that has, you know, 0, 0, 0, 0, 1, 0, right? And it'll create the graphic of Tetris with the block there. And if we have time after that, we're going to try and make some basic functions to move the blocks, okay? I don't know how long it'll take. How far we'll get, but that's the start. We're gonna draft up a bunch of functions that will plot the game state, and when I say game state, that's what I'm going to refer to as this matrix with all the data of, like, where the block should be. And then maybe the ability to manipulate the game state, so move things around in that block. Alright, let's go to work. So what we're gonna do is we're going to start with some basic functions to do the basic things like generate the empty rectangle that should be the plot, right? So what we do care about with Tetris is played on a 10 block wide, 20 block high field. So that's what we're going to aim for. MATLAB is fairly good at creating plots that are, you know, whatever specific size you want. I need to really quickly look up the aspect ratio command. But if we have, we'll say x is equal to 1, 2, 3, 4, and we'll set some y's equal to, just to demonstrate, 4, 7, 1, 6, just random numbers. And what we're gonna do is we're gonna plot x and y. I'll show you how easy it is to generate graphs. Okay, so now you can see, we can make this graph, but it doesn't have that 10 to 20 aspect ratio, and it doesn't have that 10 and 20 sort of scale on the axes. So what we're gonna do is we're going to change that. First of all, what I have is the command for aspect ratio. I've just looked it up. It's pb aspect. Aspect. And then what you enter is a row vector of how much the ratio should be for each. So what I think we want, if I remember right, is x and then y and then z. So since our x needs to be half of what our y is, that's 1 and then 2 for the x and the y. And then our z can be whatever, because we're never going to use the z. Okay, quickly test it. And now the plot that we just showed shows up on that aspect ratio. So we're good to go there. Okay. Now, the second thing is we want to adjust our axes so that they also include the correct numbers. MATLAB axis settings, Okay, so I looked up those. The command to set the X limits is xlim 0 to 10, because we want 10 in that direction. The Y version is ylim 0 to 20, because that's what we want in that direction. Plug them in and let's see if it works. And so we're looking good, right? Basics of the playing field that we want are already showing up. Now, what we plotted is obviously was just some random string. But now what we need is we need to be able to generate boxes. So what I think I'm going to do is I think I'm going to make a new function. And the name of the game is we're going to make a function that will plot a single box. And then we're just gonna call it a bunch of times every time we need to plot a box, so that for our matrix, we'll just call it, 200 times for each spot, and it'll plot boxes every spot it's supposed to have one. Okay, so our output argument, I don't think we need, but I guess it's fine to leave them and just not create anything. And we're going to name this draw box. Hi, mystery. What we need for this is we need to give it an input of where the box should be. So that's going to be an X position and a Y position. Any chance I can make the text bigger? Bam, 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 bam. Let's think. Is there a way to do that? Big enough? Need to be bigger? I actually didn't even know you could do that in MATLAB. But it makes sense. Gotta help the people with worse eyesight. Actually, I want to do bigger. Yeah. Yeah! Okay, so here's the deal. When we give an X position and a Y position, that's only really one spot, right? But what we want is we want a complete box. So we need to define corners based off of our position. Hi, Ash. How are you? And I think what logically makes sense is actually to define one of the corners as our, our X position and Y position, define it based off one of the corners instead of the center. So I think what we're going to do, just with some minor foresight, is I think we're going to define our input spot as this corner. And then, using that corner, we're going to generate the locations of the other corners. Okay? So based off that, if our X is for here and our Y is for here, we now need to generate a point 1 to the left, 1 left and up, and 1 directly in. So what we're going to do is we're going to do corner x's, corners x is equal to the initial position, which will be X position. And then it'll be that same position 1 to the left, which will be -1. And then the top left corner will be the same as that, which is still the initial position -1. And then finally the top right corner will be the same value as the X position. So that's our X coordinates for our corners. we'll do the y coordinates for our corners. Corners y. You have carrot cake? I want carrot cake. I'm actually so hungry. I've been trying to sort of maybe lose a little bit of weight. So I'm trying to eat less. But I find myself craving cookies. Okay, y positions. If we go in the same order, right? Because we have to go in the same order of... This was our initial... Wait. Well, same order of... This was our initial. This is our second point. This is our third point. And this is our fourth point. Then, the first point is obviously our initial y. The second point does not move in the y-axis, so it will still be that. Then both the third and fourth points will move, and they'll be 1 up. So both those will be +1. Okie dokie. And then all we're gonna do is we're gonna do plot corners x, corners y. Okay. So this function, drawBox, should go off an x and a y, and it should plot us a box. I'm gonna save that. So if we run this, it should plot us a box. We call that draw box. We'll say that we wanted it drawn at with an initial position of 3, 4. Does it work? Okay, it plotted it, but it changed all the aspect ratios and all that. So what that means is we need to set the aspect ratios and the limits after we draw it. Good to know. Also, we need to reconnect the box because it didn't go back to the initial point, so we need to add one last point to each of these. Hit save. And then, draw box. 3, 4. Have all this stuff after it. And then we'll run it again. Okay. Cool, so now we have something that is putting out our general space. And we have something that can put individual boxes into it. So now the game plan is we need to make something that will take an entire matrix that we'll call the game state. Game state. And it will systematically go through that entire matrix, go through every single entry in the matrix, and plot boxes where they should be. So that's going to be systematically, to me, what makes sense is to do this one, and then this one, and then this one, and finish the row, and then go down, left to right, top to bottom, the same way we read English. So we'll we'll call this a new function. And we'll call this draw game. I'm not that smart, Ash. I am just bored. Bored enough to try and make this thing do things it's not supposed to do. Okay, so draw game is going to take in an input that will be game state. And then what we'll do is we'll size the game state. So, let's experiment. If x is equal to 0... Can we make this one bigger? No, we can't make this one bigger. Unlucky, unlucky, 3, 4. Right. Size x. I just want to check that the command works. Yeah, spits out 3, 4. Okay. So what we're going to do first is we're going to check the size of the game state. Size game state. Size, yeah. And we're literally going to call the output of that size game state so that we don't have to worry about remembering what things are called. They're all very straightforwardly named. Game dev arc? If only. If only. You know, I remember in college I went to a career fair, and I went to one of the booths was like for Sony, I think. And they were like, "Oh yeah, do you know how to code?" And I was like, I mean, I know MATLAB. And the lady was like, she actually gave me the weirdest look. She was like, yeah, maybe, maybe you should focus on hardware. Maybe you should focus on hardware. Okay. Anyway, so what we need to do is we need nested for loops, one to go left to right and one to go top to bottom. We'll start with the top to bottom for one, yeah. What do we want to call it? Y location is equal to 1, 2, 1 until the Y size of the game state, which is size game state 2, wait, no, 1, right? So matrices are kind of weird because whenever you're plotting things, you want to go X, Y, right? But matrix notation is actually, first is what row it's in, and then second is what column it's in. And the rows go top to bottom. So really, you have to sort of get used to doing things sort of backwards, because the first thing that you're going to put in is, you know, how far up or down it is, because that's what row it is. And then you need to go from top to bottom, which is kind of nasty. Because you'll just forget it at some point when you're mixing up plots and plots and matrices. She can eat her look today? I don't know. I'm pretty sure every time I talk to a software person and I'm like, I could do software. I'm pretty good at MATLAB. They give me the same look. Okay, so we have one for loop for the Y's, and now we'll do another for loop for the X's. X location. And we have to end that loop too. Okay, so now we have a loop that is going to check that has the equivalent number of entries as our matrix. Math and its origin at the bottom left, how inconvenient. You say that, but matrices are math, and they start at the top left. How silly. How silly. Okay, so what we're going to do is for every point in the initialized game state, we're going to check if that location, game state, Y location first, Annoying that we have to do y first. X location. And then what we're gonna do is we're going to check if it is... Forgive me if I've forgotten the syntax. We need to check if it's 0. And if it's not 0... Not equals is spelled... Oh, I'm so glad MATLAB tells me what I'm supposed to do. Okay, it's not the exclamation point. It's the freaking squiggly. Okay, so if... And... If it's not a 0, then what we're going to do is we're going to call that previous function draw a box. Y location. X location. Nope, frick, you see that's just what happened, chat. That's what happened, because now I got into matrix mode and I'm doing Y's first. But draw a box goes off coordinates, so it's supposed to be X first. This is why we can't have nice things. X location. Y location. And then... Oh, something that we do need to do is we need to turn hold on. What hold on does is if you plot multiple things in succession, right? What happens is the second plot will basically delete the first plot, and the third plot will delete the second, and so forth. Everything, it'll just only hold on to the most recent plot. What hold on does is it makes it stop deleting previous plots. Okay? And then after that, we need to make sure we do that same... Set the aspect. Okay, and actually what I want to do is I want to do... Instead of setting it to always be 0 to 10 and having static limits, what I'm going to do is I'm going to make them change and automatically always fit whatever game state is. Size, game state, X is 2, and then Y is this 1, if I remember it. If I remember right. Okie dokie. Cool. Clear. CLC. Just gonna clear everything on your workspace. And then what we'll do is we'll generate a testing game state, which will be 0s, 20, 10. Oh, I forgot that I didn't show it to not show. So this is our testing game state. Right now it's empty. Gonna make it more like what we expect it to look like. Since it's so fat, just the way that all the columns are fat, gonna adjust it. So if we plotted this right now, it should plot nothing because it's empty. But what I want to do is I want to test if it actually plots stuff. So I'm gonna put some stuff in random boxes. Let's make like a little smiley face. Okay. So now our X is set. We'll save this function. Draw game X. Let's see if this works. Okay. Index position exceeds array bounds. Index must not exceed 10. Let's see. Not what I wanted. Not what I wanted. I regret everything. 4. Game state location. So at some point what we tried to call was an X location that did not work. And let's add this just so we can debug. Draw now. That'll force it to plot every time that it works, and then eventually when we get to the one that doesn't work, it'll spring its error. Okay. Hit save here. Thanks for throwing things at me, Ash. Also, thanks for the hydrate. Take a quick sip. Okie dokie. So let's try the function again. Okie dokie. So we managed to plot the first 10 fine. It seems like we've got 10 boxes here. So somehow oh, we set our for loop for the X size wrong. So it was going to 20, I think. Let's try it again. Let's try it again. Okay, chat. Okay. Now, I am noticing that it is upside down. Right? Because but our game state looks like this. It has all the ones at the top, and it has a smiley face. And this is all the boxes at the bottom and an upside down smiley face. And I'm realizing that is also because of the freaking notation, right? Because when we plot things, we go bottom to top. But our matrices are organized top to bottom. So when we're like iterating through this guy, through 1, 2, 3, right? We're going along the top. But when we're plotting, if we plot like our first position, which this is, 1, 1, then that's here. That's 1, 1 at the bottom. So I think the easiest way to rectify this problem is to make the Y location negative. And then add 20. Let's try. Boom! It's that easy. There's our smiley face. There's our smiley face, chat. Now, something that I think is like a little bit... how do I put it? Distracting is that they're all different colors. So what I'm gonna do is I'm going to boom, 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 set the plot to black, I think. Hold off. Okay. Save that. I wonder if I remembered how to do the syntax and I did the syntax for that properly. We'll see. We'll see. Now they're all black. Easy. Easy, chat. Not even difficult. We actually are cruising through this because we've not even been coding for an hour. Okie dokie. Now, what we need is, since we can plot any given game state, we need functions that are going to change the game state, right? So that, when your block starts at the top, every time the function gets called, it'll go one down. It'll go one down. It'll go one down. And there is something important about making sure that it only affects the blocks we want it to, because, you know, if you've got your T, you want this T to go down, but anything at the bottom, right, obviously should not go down. So we need to be able to differentiate these blocks from these blocks. I think the easiest way to do that is with our matrix. We'll have these quote-unquote permanent blocks, and they'll be ones, and I think this, you know, falling block can be 0.5. Sinking blocks through the floor is a high-level technique called hacking. Yep. Worse than that, I'm pretty sure in MATLAB, if I try and tell it to, like, go to the next level of the array, that of the matrix, it's just gonna break the script. But, okay, so the new plan is we need to make a function, and we'll call this function, move down. Move down. Again, what we're gonna do is we're gonna feed it the game state. And what it's going to put out is it's going to put out a new game state. So that way, you know, you now have the new matrix representing where everything has moved to. So we're gonna do, we once again need to check through the entire matrix, so we're going to use this same for loop structure. And how do we want to do this? We need to check all the locations, but what are we checking for? We need to check that they are not 0. Okay. And then if they are 1, we need to put them into the new game state in the same spot. If is equal to 1. Man, we're getting deep into the the tabbing. Then we'll say, start off, we should make new game state the right size. New game state equals zeros. Size game state. So, new game state. At that same location will be set equal to whatever it was before. For all of our permanent blocks. We also need to, if they are falling blocks, move them. So what we're going to do is this same if statement, except, what do we want to call it? Well, falling blocks will be not 1, anything other than 1, just in case we want multiple versions, I guess. And it'll be fine because they won't be zeros because they won't enter this loop if they're zeros. And, new game state will put that same value into the block below it. At Y location +1? -1? Let's try it. Let's try it. Before we try it though, we have to make a suitable game state, so we're going to make all these x equals 0s, 20 by 10. So we're going to make this one a falling block, this one a falling block, this one a falling block, and this one a falling block. And we'll make all of the bottom, besides one, we'll make all of the bottom permanent blocks. Do we need anything else? Oh yeah, we need to draw the game, I think. So then we'll call draw game. And let's go for it. Move down X. Okay. Okay. So we have gotten it. Okay, so right now the T is centered at, 14 along the Y-axis. If we call it again, it should drop one. Oh, wait. We didn't update. Okay, so instead of just calling it, we need to do X is equal to move down. Yeah. Okay, now we call it again. Did it move down? It did move down. It's bothersome that I have to keep clicking back. But if we keep calling it, does it get to... Yeah, it goes... Okay, cool. Something that I am foreseeing, though, is that right now it's not checking if it's going to stop. Right? We don't have any logic that says when this T gets down here, we need to turn it from a falling block to a temporary block. So, how do we want to do this? Because if we... Oh wait, no. Easy. It's so simple. All we do is we check if it's about to collide with something. So for instance... here, it's about to collide with something. All we do is we check if it ever is about to collide. Then all we do is we make our current game state stay permanent in all blocks. So, collide, huh? Yeah, exactly, Ash, exactly. Zero lock delay? What does zero lock delay mean, Penboo? If... Okay. So what we have to do is we need another set of if statements. God, we're so deep into the tabs! We've gone very deep. The location below it, which would be game state. Is not equal to 0? 0. Wait, no. If it is equal to 0, we'll move the block. And if it's not equal to 0, else if... Then what we'll do is we'll... set a variable. We'll set... collision equal to 1. And we'll initialize collision here before that whole loop starts at 0, right? So it's gonna run through, collision's gonna be at 0. If something is going to collide with something else, then collision will flip to 1. And if collision flips to 1, then all we're going to do is our new game state is equal to our old game state. If collision equals 1. And block delay is the amount of time after touching the ground / other places before the piece locks into place. I've interestingly thought of that. My plan is, all I'm going to do is I'm going to code this function that brings the block down. And for timing, all we're going to do is we're going to call this function once every second or whatever. So it's only going to lock it every time that 1 second tempo gets called. Because, how do I explain this? The way we're working right now is, if we've got, this scenario, right? Actually, it should be here. What happens is, when we call it, it'll create this. Right? But, after the first call, what it's created here is still going to be permanent, 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 but these will still be temporary. They'll still be 0.5s. Until we call it again at the next time, and that will lock it in by turning them from 0.5s to 1s. Speaking of, we need to add that logic. So, after if we've done collision detection, then we need to quickly run through and change all the temporaries to permanent. Yeah. We're going to smart indent this because it looks kind of ugly right now. Smart indent? Here we go. Here we go. You gotta keep it pretty, right? I'm sure all the software developers agree. And then... yeah. We need to set it to check for them if they're not equal to 1. Then we'll set them equal to 1. Equal 1. Okay. This is kind of ugly for one single function. But it be like that, chat. It be like that, chat. Let's do, of course, nothing works until you've tested it, chat. Remember that. So we have to test it. That's like rule number 1 of integration hell. Integration in general. Nothing works until you've tested it. Okay. So... we're gonna start with this position. Did it go down? Did it go down? We broke something. Because it's not going down. What did we break? If game state... okay. Hola. We need to figure out where we're breaking things. I have a feeling it's detecting a collision, but the question is where? New game state. The position below gets set to this. How are we detecting a collision? Game state equals X. Ah, I forgot to silence it. Show me. Okay. So it did detect a collision. It shouldn't have, though, because we're here. Interesting. Collision. What we're going to do is we are going to... oh, I know what happened. I think. What happened was... This is why we test things. This block here, this middle block of the T, at the cross of the T, is detecting a collision with the block directly below it. So what we need to do is we just need to, instead of checking if the position below it is 0 and saying that's good to move, what we really need to do is we need to check if the position below it is 1. And if it is, then it's not good. We need to flip this logic. Okay. Save that. Alright, let's try it again. Okay, it dropped. It dropped again, I think? Question mark? and it dropped into place. Now the question is, if I run it again, does it break because it tries to drop through the floor, or does it stay? It breaks. It breaks. Okay, so why is that? Oh, it doesn't have to drop through the floor to break it. It just needs to check the one below, right? Because right now what we're doing is we're having this box triggers a check right below it, and right below it doesn't exist in the matrix. So what we need to do is we need to give this an OR statement. Or, is there a better way? We should just check if, before we do anything moving the block. Bam, bam, bam. Hola. Mess with our thing again. 0. .5. .5. .5. I really quickly want to check if it works with the collision detection just with the blocks below it without dealing with the bottom of the floor prop. So what we're going to do is we're going to run it with an L. Does it work? I think it worked. But I actually didn't set our initial spot up very well. 0, 0, 0, 0.5, 0.5, 0.5. Okay. So we have RL. It is falling. Now it's in a position where the next time it's supposed to fall, it should lock. And right now it is still, the block states are still considered quote-unquote falling. We run it again, and the block states are still considered quote-unquote falling. Interesting. So somehow we are not setting them equal to 1. Okay, so we're checking every location. If it's not equal to 0, and it's not equal to 1, then it should get set to 1. But why isn't it? I'm gonna quickly change the variable we're messing with equal to make it, to call it game state, just so that I don't have to keep changing it. Game state equals to X. I'm still keeping the old game state. Right, so if we run through our loop checking everything, right, as we're moving it, we trigger collision. Now, once it's triggered collision, our new game state becomes what our old game state was. And then we iterate through it. And every it needs to be new game state. It needs to be new game state, not old game state. I see. Take 2. Take 2. You know, the people who have the tenacity to do this professionally are like... I feel like I would end up throwing a brick through my window. I would end up throwing a brick through my window. Okay. So here's our L. It's falling. It's falling. It's now at the bottom position, but it hasn't locked yet. Did it lock? Yeah, it locked. There. Okay, there once. Excellent. Mucho. Excellent. Now to address that bottom of the floor, checking through the bottom of the floor issue. My thought process is Okay, so this part of the script is for anything that's permanent. We can leave that alone. This part of the script is for anything that's falling. All we should do is we need to only run this part of the script that's for falling blocks if it's not the bottom row. Because if it is the bottom row, then we don't need to check any of this. We just immediately declared a collision, right? And I think that... Okay, so that needs to get tucked into... here. Wait. Hold up. Hold up. Yes. Needs to be tucked in here. I think. If Y location is not equal to the very bottom row, which means size of the game state 2. No, size of the game state 1. Frick! Matrices and plotting having opposite notations is actually awful. Actually awful. Smart indent. Because things are getting really nasty looking. There are so many ifs. There are so many ifs. Okie dokie. So now, before we test this, we need to set it up in a way that will test it. So, freaking... how do we want to set it up? We'll set it up with a line. Boom. 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 Oh, there's one other thing we need to do. We need to set it so if it is at the bottom... if it is at the bottom, it needs to trigger a collision. And that means we need to check this before we go into this if loop. Or do we? We can just check. We will do a check. If it's at the bottom, else. If it's at the bottom, then we'll check if it's falling, quote unquote. And if it is falling, then we'll set it to collide. Okay. Smart indent again because it's freaking ugly. Super, super ugly. Am I missing something? I'm missing an end somewhere. I think. Smart indent, don't fail me now. Okie dokie. Artichoke. Let's run it. Let's run it. Rob? 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 Okay. Now it's at the bottom, but it's still in its falling state, and now's the moment of truth. Does it break? Does it break? It breaks. Ah! My wallpaper? What? Huh? Huh? Are you looking at my wall? When did I show my water? It flashed on screen for a second. Make a hidden bottom row? Interesting idea. Then I have to change my matrix to be... Oh, is it just showing every time I flash my... this? When I flash different screens? Or if I hit tab? Or is it just like periodically flashing? I made sure nothing on this monitor was sensitive first, though, at least. If do. Game state location, do. This is all for falling blocks. This is our loop of code for when we get to the very bottom. Oh, duh. It was still checking below it. Take two. This time without breaking. Okay, and it locked it in. You think it's when I hover the window preview? Oh, yeah, that makes sense. That makes sense. Okie dokie. Artichoke. What is this music? Background music. I hope I'm not gonna get DMCA'd. Okay, so we now have a function that effectively drops things down. So what we now should do is create a way to call the function whenever we need to call. Enjoy your snacks. Enjoy your snacks, Ash. This is already way farther than I thought we'd get along in this stream. Let's see. Actually, is that what we want to do, or do we want to make a timer that runs this? Make a bootstrapper. Okay, let's do the bootstrapper. TLC. Okay, game state equals zeros 20 10. Easy. While game running is equal to 1, we'll do game running equal to 1 as an initialization whenever you run this. We'll also do a tick command. So if you're not familiar with MATLAB, MATLAB has this cool thing called tick and talk. So ticks basically starts a stopwatch, and talk gives you how much time has passed since the tick. Okay? So what we're gonna do is we're going to, while the game is running, if talk is equal to tick plus how long do we want to give ourselves? 1 second. 1 second between everything. Then we're gonna call move down. This background music goes kinda hard. Game state equals move down game state. And whenever this happens, we're gonna reset our stopwatch, so we'll tick again. And end. What else do we want to do? We want to make this run, because we don't want this to run indefinitely. We need something that's going to inevitably tell us that this is done. So we're going to say total time at the beginning is 0. Total time equals 0. And we're specifically not going to suppress that so that we can watch it tick in real time. Total time is equal to total time plus we should make this a variable instead of 1, so that we can alter it as needed. Time between, we'll call it force time. Force time. Plus force time. And we'll call it that because that's the amount of time that passes before it forces the blocks to go down. Total time equals total time plus force time. Okay, and then if force time is greater than 15, right? So we'll stop this after 15 seconds. Then game running equals 0. So it'll turn the game off after 15 seconds. Easy peasy. Now, the next thing is we should set our game state to not be 0. So we're gonna do game state 3. Wait. 1 being the top, and then 2, 4. 4 is roughly in the middle. equals 0.5. So that'll set a falling block there. We'll do that, and we'll make a T. 5, 6. 5, and that's on the second row. Actually, let's run it for 25 seconds so it can fall all the way to the bottom. Here goes! Something didn't happen. Something went wrong. Or it's running right now, and the timer's ticking and we're just not seeing results yet. Has 30 seconds passed? Interesting, interesting. Let's check all of our things. Does this properly generate something? Oh, we shouldn't have set it to perfectly equal, otherwise the timing's not good. We need it to be greater than. Here we go. You're right, Penbu. That's exactly what happened, I think. Still nothing's happening though. If talk is greater than tick plus force time. Kill it. Or wait, I guess we should wait the 25 seconds and see if something happens. No, I'm done waiting. Nothing has happened, so somehow we have not... X equals... What is talk? Talk is 10, so this should have definitely hit. Oh, it's... I'm mixing up variables. It needs to be total time. Thank you for finding all this stuff for me. This is why I could never be a software person, because the freaking missing different names, or misspellings, or semicolons would ruin my life. I don't like this though. Here, so C. Let's just run this. If talk is greater than tick plus force time. Let's see if it runs even once. It does not run even once, so the question is, why is talk not triggering? else. Let's just verify. Print. Talk not trigger equals 1. And we won't suppress that, so it will print. Okay, so talk's not triggering it. Why is that? Force time is 1. Talk plus force time. Or tick plus force time. Tick plus force. Oh! I know why it's not triggering. I'm not supposed to be using tick here. Okay. Because if I use tick here, then it checks the current time. It, like, checks the right now of the stopwatch. What this needs to be is this needs to be a variable of last tick equal to tick. And then it'll be last tick. If talk is greater than last tick plus force time. And then whenever we redo it, we need to last tick equals tick. Here we go. Last tick? Wait, why is there unrecognized function or variable? Is this not a valid? Oh, I used a K here and not there. Frickin'. Let's go. Why are we not printing? Last tick equals tick. Is that how it works? You might be right. Ah! Something's still wrong. We did call tick here, so talk should advance. What the heck? Clear, CLC. Oh, we're running things. Clear, CLC. So now we've got something weird going on because our integration hell, save me! Save me from integration hell? Okay. Whoa, whoa, okay, something happened here. Something happened here. But we've now managed to trigger. Okay, so what we need to do is we need to call tick so that we start having a timer. We immediately initialize a variable based off that initial timer. And then we're constantly comparing equals top. Okay, but my question is, how did we plot something so freaking ugly that it was not even the right... This is... Whoa! Hey, cat goes mute. Okay, so we're plotting something. It's, for some reason, lost its aspect ratio. Also, it's bugging the frick out. Okay, move down. So what we're calling is move down. Move down should call draw game. And draw game should have the aspect ratio. Oh, wait, no. Draw game should draw after setting the aspect ratio. Let's try it. Let's try it again. Is it bad that... Hell yeah! Hell yeah! Is it bad that all I do when I'm coding is I just try different things over and over again? Maybe. Maybe. This is how I troubleshoot in real life too. Let's go, chat. Let's freaking go. Okay. And freaking tastic. At some point you have no brain power, so you just throw stuff at the wall? Yeah. That's, Okay. Fantastic. So, the next steps are either we create functions that move things left or right, or we create a function that, when we hit the bottom, generates a new block, or we implement the ability to press buttons to call things. I guess the ability to press buttons to call things is not helpful, because unless we can move left or right or turn, we're not going to be able to really check it. So I guess first things first is to make move left and move right. Here we go. New function. Move left. Now, there's something really great about this, in that more or less it's gonna be moved down with some simplifications. Okay. All we care about with move left is we actually don't care about it falling through the floor. And that was this block of code. Before I was about to delete it? No. Don't delete it, chat. It's a mistake to delete it. In case you fuck up and you're deleting the wrong thing, we're just commenting it out as about to make a a large mistake. Do I not use comment? Here's the thing. It's not power. Cat goes mute. It's disorganization. This is the code self-documenting? No, because I can't. I need to parse the line to tell what it is. But I guess I should document right now. Because this line is basically checking that it's not at the bottom. Speaking of, did I... Yes. Okay, yeah. I commented out the right things. But this comment says, you know, if it's something that's falling. This comment says if it's not empty, whatever. This comment is for all the blocks that are permanent. We need to leave that. Okay, so this is what we care about. This is the blocks that are falling. And we're moving them left. So what we need to check is if there's something directly to the left, which means X location -1. Actually, we should uncomment this and repurpose this code. Repurpose this code. Instead of checking for it to be at the bottom, we check at it to be the very far left. Is 0, right? No, 1. If X location is 1, that's the first index. We of course need to uncomment out this. Oh god, my brain. Am I able to convert this into an executable? Yes. MATLAB can create executables. Dude. X location. So if it's not at the very left, it'll move to the very left. And if it's not at the very left, it'll move on the left. If it is at the very left, uncomment this again. If game state equals locate. Wait. Okay, so we check. Boom. We check if it's not 0, which means it is a block. Okay, so it is a block. And then we check if it's a falling block, right? Because it's not 1. Permanent would be 1. Okay, cool. Then yes. Then we check if it's along the very edge. If it's not along the very edge, we move it 1 to the left. And if it is along the very edge, we trigger a collision. But something that should happen, is very different here when moving left is when we trigger collisions, they do not become permanent, right? When we were dropping, oh god. When we were dropping this piece, right? And we were moving down. When this triggered a downwards collision, this piece had to turn permanent. But now, what we're checking for is collisions against the wall. If this is a collision, we don't want it to turn permanent. We want it to keep falling. So we can actually get rid of all this stuff that turns it permanent. Sticky wall? And that would be really awful, Penbu. I feel like that would be really, really awful. Not only sticky walls, that means if you... if you accidentally hit move left while there was a permanent block to the left of it, that block would also be sticky. Okie dokie. I'm glad I commented the previous stuff out instead of deleting it. Okay, smart indent saved me from myself. That hardly changed anything, okay. Okay. We're going to quickly... Oh! What? I pasted more than I should have. Move... left. Oh no, why is it called Untitled? Frick, frick, I don't want it to be called Untitled. Does it detect the... Okay, okay. Woo! Smart comment. There's smart indent. Okay. Back to testing. Of course, because of course we need to... We need to test everything. 0.5. 0. 0.5. 0.5. We'll do a square this time. Okay. Game state equals move left game state. Okay, so this is where we're going. Does it move left? I don't think it moved left, chat. I don't think it moved left. Okay, so what that tells me is somewhere here, we've triggered a collision when we shouldn't have. It's... We could have triggered it here. Or here. And all we'll do is we'll just... get drawn out here. On this loop. Draw now. Wait, we can't hit draw now. We haven't formed anything. Interesting. What we'll do is we'll set it for all the locations that would be failing. We'll set their value equal to 5. Okay, so that if these change to 5 now, then that means we're triggering here. None of them switch to 5. Does that mean they're triggering here? Here they'll switch to 7. Man, this background music is crazy. They don't switch to 7 either! Oh no! You're right. Henbu, what would I do without you? They still don't change. Okay, so something's happening here. What is happening here? What instead I'll do is I'll print. I need to really quickly check this. Does this work? Collision. Actually, no. I don't even need to do that. I just need to unsuppress. Okay, so we are not getting to this point. We are not triggering a collision here, because that's not showing up. Is this one showing up? Also not printing. You need to quickly verify that things... No! Okay, this is bad. This is bad. Print... collided. And I'll do something here to make sure I have the syntax working. Start. It's not even printing stuff. It's not even printing stuff when I initialize. Does that mean it doesn't... Either I have syntax wrong, or it doesn't print things in functions, which seems wrong. I'm pretty sure it should print stuff in functions. MATLAB print. Oh, it's cause I have syntax wrong. Okay. Display. Disk? Yep, disk. Okay. I don't think suppression on when I'm calling it affects prints for display. Yeah, so it still it does show. Okay, now it does show where it's not displaying this, which means we're not getting here. Does it show this? Collided 2. Okay, we're not getting here. Where are we getting? Okay, so we're iterating, We're checking if the value of a box is 0. And then if it's not 0, we're checking if it's 1. And if it's 1, then it stays the same. This should not affect anything. And then if it's not 1, we're checking if its location is 1. If its location is not 1. And then... Interesting. So if it's not... My brain is hurting. Okay, we're checking if it's not along the left wall. If it's not along the left wall, then we're checking... Yeah, this is if we're if it's not along the left wall. Then we're checking if it's next to a block. Okay, so this should never happen because none of them should ever be next to a block. So this should happen. Display moved. Okay, so things are moving. Because it triggers this. This is triggered 4 times. Because it says moved 4 times. So how come... Wait a second. Things moved down. Things moved down. Why did things move down? Here we are. I see. We still had code from the move down. Okay. Okay. Okay, we're here. We're directly above the right side of the T. Now, okay. Okay. We're cooking, chat. Excelente. Mucho excelente. Okay. Moment of truth. It's against the left wall. Does it break when we try and move it left? No, it doesn't. Woo! Okie dokie. So now, let's test it within... Let's test it within the confines of our bootstrapper. How do we want to iterate it? I want it to go... 25... mod... 6? Wait, is it... What's the syntax for mod? 25... sub 4? Okay. Eh? Okay, okay. So what we're going to do is we're going to make it every... fourth move, it's gonna move left instead of moving down. If mod total time 4 equals 0, then we're going to do move left. Else, move down. Alright, chat, let's go! Oh shit. We should have initialized... Wait. Wait, what's going on? Oh, we're not ticking our timer. If... Okay, we can remove this. So we're checking if we should tick, or if we should make a move. We're then checking if that move should be to the left. And if it should, then we move left. If not, then we move down. Why didn't it? Okay, this looks right. Here, CLC. Left, down, 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 left, down, down, down. It's gonna try and go left and do nothing. Down. Okay! Chat, we're cooking! We're freaking cooking, chat! Hi, Gojo, how are you? Okay. So, now here's the thing. Tetris needs to be run by... Actually, before we do anything else, let's just make another one that does move right, and we'll just have them both. Move right. This is a -1, needs to turn into a +1. This is a -1 that needs to turn into a +1. This one, when we check the location, we need to use the very far right corner instead of the far right side instead of the far left side. So that's size game state 2. Let's quickly check that we can make it move right. Game state equals move right. Game state. Okay, so we're in the middle. We have something not suppressed here, which is freaking ruining us. There we go. And it's moving to the right. Excellent. Most excellent. And it's also not breaking. Okay. Fantastic. We can comment these things that we're displaying because they keep popping up in the Command window. Hi, Azure Empress. Welcome to stream. Thanks for the raid. I'm here working on the beginnings of Tetris in MATLAB. How are you guys? What were you up to with your stream? Okay. And I'm going to quickly check if this move right works. Move right. In the context of our bootstrapper. You're working on your RPG and you have to ready to run. That's fine. Get some rest. Get some rest. MATLAB? Yeah. You see, my secret is I was never a software developer. I went to school for mechanical engineering, and so they taught me no languages. But we out here making it work. Okay. Let's see if this works. We got a T. This is how we're gonna initialize. Alright. So here's what should theoretically happen is when I run this, supposedly, it should print us a plot with the T in the middle of the game board, and it should slowly drop down, and every 4 moves, 1 will be the left, 1 will be the right, and 2 will be down. Whoa! Down, down, left, right, down, down. Hell yeah! Do you have a question, Cosmic? Okay. Okay. This is fantastic. And things are still displaying because I forgot to comment these out on my move left command. Comment. Comment. I'm feeling pretty good about this, chat. For something that I've only worked on for 2 hours now, essentially having all the movement functions now. Things that we still need to add are, we still need to add the ability for when a row is full to delete it. We still need to add button pushes to call all the functions. Those are pretty important. We still need to add the ability to generate a new block as soon as your current block has fallen all the way. But I'm feeling pretty good. I just want to make sure it's not printing anymore. Why is it still... It's still printing a lot. Oh, it's not printing a lot. It's only printing last tick. Okay. Do I plan on implementing rotations? Yes, I do. Although I'm not sure the way that I would implement rotations is the way that Tetris does them. Because my plan for rotations is every shape I'm going to pick one singular block in the shape and I'm going to make that the quote-unquote cornerstone, and all the rotations will be about that cornerstone. I'm not sure if that actually is how Tetris works. That's just a way that I could see things moving. If we needed to do rotations, that is going to require some... It's gonna require a lot of debugging is my suspicion, because every time you rotate, you obviously need to check the things that will be below or to the left or right. Except for the I and O. Okay. Yeah, so, I mean, my game plan for the rotations... Let's see. I wrote on the background here. Frick. Okay, so my game plan for the rotations is right now we have our matrix that supplies our game state, right? With, you know, 0.5s for falling blocks, right? And 1s for permanent blocks. My plan is to do... We'll assign each shape a different number, so we'll do, you know, T is 1, normal S is... normal S is 2, right? And what we're going to do is for all of our falling blocks will have cornerstones of this middle, we'll say it's the cornerstone for the T is the center. That will be 1.5. The cornerstone for the S will be 2.5. Oops, 2.5. And so on and so forth. And then what we'll do is these guys, based on which orientation it is, will be 2.1 or 2.2 or 0.3 or 0.4. Actually, we should do it the other way. The cornerstone, what we'll do is the cornerstone will be 1.1 or 1.2, etc. And that will already give us all the information about whether it's down T will be 1.1, right T will be 1.2, and so on. And basically all we're going to do is we're going to just worry about the cornerstone block. We're gonna read it, we're gonna say, oh, it's 1.1 right now, it needs to turn into 1.2, and then we're going to draw all the other blocks around it, which will be, you know, a 1.5 here, a 1.5 here, a 1.5 here. And then every time it's just gonna rotate the cornerstone between one number to another. And then it'll build all the side blocks around it. So yeah, that's the plan for rotations. There's gonna be a lot of freaking ifs. There's already so many ifs. This is so ugly. But I think we can make it work. I think is definitely a not today problem. I'm wondering if I can really quickly implement button pushes to call all of our functions. You don't think you've thought to do it that way? I don't know, I've just been like wondering like, what is a way that makes sense to do and will not require like incredible computation for every single like value in the block, right? I want to compute once. Let's see if I can get down really quickly the ability to call functions with button pushes. MATLAB. Check if button is pressed. I'll be honest, this is one thing that I'm really not good at with MATLAB. I have not touched UI elements in a very long time. We'll see. Thank you, Gojo, for throwing things at me. Man, my brain is like starting to fry, I'm not gonna lie. But I would like to do this quickly because we made so much progress and I want to keep the momentum really quick and hopefully sort it out. Oh, I'm asking about buttons, but I really need to be asking about keyboard keys. How to determine if a key is pressed. That's a script that's already written. That's not what I want. Okay. So what I have... This is some other guy's code, but I'm going to quickly take a look at it and see if I can discern things that I need to. Okay. I'm seeing this is important. It is calling this function. It's checking what is push. Can we steal just this and automatically set this to right and left arrows? Let's see. Let's see. So right arrow should be game state equals move right. Game state equals move left. Oh, we need to give them inputs for these functions for current game state. Okay, so supposedly this worked for something. I don't really want to... I'm wondering what this H-fig is. But let's try it. Let's try it. And we're going to, before we do this, I want game state to be global. Or is it global game state? Is that the syntax? That looks right. I don't know if this is gonna work, but let's give it a shot. Oh, wait. I need to quickly remove all the stuff that was automatically forcing it to go left and right. Comment. Tetris. Space? Question mark? Not question mark? We can't have space. Okay. Oh. Pressing arrows is doing something. That is closing the window. Okay. Oh, it's because this figure, I think... Try now. No. Nothing, huh? Nothing? Interesting. The stack overflow way? I mean, this is just how people code, isn't it? My understanding is, like, there is innovation, right? But most of coding is finding something that is already existent and repurposing it in a way that fits your needs, right? You want to do as little reinventing of the wheel as possible. Let's see, there was... which key is... I'm starting to think that this... I'm starting to think that this script that I took from this person is maybe not the one that I wanted. E-press... Let's try this. Function definitions are not supported in this context. What if we just call... Dropbox? What do we... Oh? Sorry, I'm casually looking through a bunch of MathWorks forums. I guess you guys can look with me. Not that you guys are probably able to read this. Real-time detect key press. That's the one that I... Okay, so... let's check something. clear. So you'll see. Use our bootstrapper, just the initialization. All set. Ooh. Press function. And move down. Game state. How are we supposed to get this to work? Okay. I think my brain's fried. Frick. I think my brain's fried. I think I will sleep on this and deal with the consequences of my actions keeping me up at night for the rest of the night. But I have to clean my house. I have to clean my house. Otherwise, the cleaning lady tomorrow when she comes in is gonna see clothes everywhere and not gonna be able to do like vacuum or any of the like things she's supposed to do. So I need to call it for the night. Thank you guys for watching. Thank you for hanging out. Let's see, hold on. Boom, boom. Since we got raided, let's see if there's anyone for us to raid. Which means don't leave yet. Oh, I know who we're gonna raid. Alright, chat. I'm sending you over to Higami. I'm sending you over to Higami. By the way, we'll continue this. We will continue this next time we stream, but I'm just too busy today in particular with cleaning and homework. So I've gotta go do other things. But I think next time we'll try and do more MATLAB Tetris? Tetris? TETLAB? But thank you for watching. Thanks for hanging out. I hope you had fun. And I hope I'll see you guys next time. Thanks. Thank you, thank you. And do everything else good to go. Yep. Bye-bye. Have a good night.